Welcome to part 2 of our interview with Andre. Last time we had a very interesting discussion about designing and selling your own product, so if you haven't seen it yet, definitely check it out. In this part, we will discuss funding, market analysis and marketing, how a simple idea created a billion-dollar company, then we will talk about selling through Amazon, certifications and much more. So let's continue where we stopped the last time. Here is my next question to Andre. Do you really think you need some kind of, or you should take some kind of, for example, financial help from other people? If yes, is it worth it?
Okay, so, well, it depends, of course, on the scale of the product, right? So if you want to start a company, right, and no one's going to give you money for a product, right? They're going to give you money for a company. And no one's going to give you money unless you've ran a company. So it's a chicken and the egg problem. So it's really hard to get money for your first company, right? Because why would I give you that when you've never ran a successful company, built a product, made revenue, made a profit, exited from the company? So it's it's a really hard sell to get people to give you money. Now, how you do this is you have a track record, maybe doing something else. So maybe you work someplace else and you develop this product and this product and this product. So I'm pretty confident you know how to build these products, right? So, and say you want to build a big product and you say to yourself, I'm going to need like 5 people to do this product. I can't pay them. That's when you need money. So if you want to have a small company, 3, 5, 7 people, you want to build a large scale product that's going to take a year or two, you're going to have to pay salaries and benefits and build out an office or have computers and all that. You're going to need money to do it, right? Raising capital at that scale where you're talking hundreds of thousands of dollars or maybe low couple million, that in itself is a big job.
Mm-hmm.
And I advise more than anything not to do it because your life will turn into 2 things: raising capital instead of building a product, and 2, you'll end up lying and compromising about what it is because you have to tell people the story they want to hear. And I don't know if you're aware, but there's an entrepreneur, Elizabeth Holmes, Theranos, right?
Yeah,
She founded this
I know. She
okay,
did something with the blood test.
yeah, so basically this is, started off in the early 2000s. Stanford, she just started one class at Stanford, dropped out, wanted to make this a single droplet of blood test, had no clue what she was doing, never started a company, not an engineer, no degree, nothing. But she honestly wanted to make this thing, and then she manipulated people into believing she could make it, and she, started raising money, $900 million and all that. And then she went from actually wanting to do it to basically committing fraud and lying to everybody about what she was going to make and one thing after another. And now she's going to jail. She's been indicted and she's going to, probably serve 20 years or somewhere around there in a month or two in San Jose, California. She's going to go get sentenced. The whole point is that you start off kind of saying, I want to build this product, but then every time you talk to a different investor, they're like, well, is it going to do this? Is it going to do that? And a lot of times you say, yeah, because you want the money, but it's not going to do that. And that would take an extra 3 months or 6 months. So you just get embroiled in this, and this happens to everybody raising money. And all you have to do is turn on Netflix or Amazon, and there's all these new series about all these entrepreneurs from the car one. What's the car where you Lyft and Uber, right? Uber, Super Pumped, and We Worked, from We Worked. Just all these stories about how people try to raise money and it's a bad idea. So I would say don't do that unless you're trying to start a company with really adult people and you guys are really focused and have a lot of experience. If you're younger and this is your first small product, I think if you can fund it yourself, that's ideally the best thing. And if you can't, then you scale it down a little bit.
Mm-hmm.
Maybe you can borrow a little bit of money. Maybe you can get a personal loan. Maybe you can put it on a credit card. But you really want to try and not go through raising money because it just creates a huge problem. It creates a time commitment. It creates deadlines. It creates stress. And then you always need more money. And every time you need more money, you have to give away more and more control. So that's what I would say about that.
Okay, I agree. How do you know there will be interest in your product? I know from my experience, I remember when I started selling online courses. Before I was doing like contracting work, and I knew I get sometimes money, and but when I sold my very first courses, I was like, wow, That's like big difference. This is really something, and it can make money. So how can you double check something like this with your product?
Well, again, you can never know for sure, but like I said, you have to kind of go out into the marketplace and look at other products that are doing this or other things that are doing this,
But
right?
you will not get
So,
the feedback from looking at the other products.
well, well, not for your specific thing, but you can say, for example, you want to make an educational toy, right? Some kind of educational toy, maybe a programmable robot, right? I can go on Amazon and I can look at the sales. I can look at how popular this is, right? I can do
How
some
how,
Googling.
how can you check sales of specific?
Well, I can look at how many reviews it has, right? And the number of reviews are going to be proportional to how many units sell. I can also just find sales. You can go ahead and in any category, if you do your research, now if you have money, you can go and get research reports by companies like Forrester Research, right? But you can just Google and say, sales of blank and sales of this, and you can go find the particular company. You can go look at the company's revenue and say, wow. And the company will say that we have this much money coming in from these product lines and so forth. So you can do research and you can figure out, this particular product or product line does sell very well, right? And then of course you can also get, and again, I don't put too much into this because people will just say one thing or another, but you can put something out there again, you can use Facebook or other media platforms and say, hey, we're thinking about making a product that does this. It's an altimeter for a rocket, so you can put it in your model rockets, but it's different from all the other ones out there because it does this. And everyone's like, if you sold that, I would buy 10 of them right now. Just instantaneously, everyone, is like, wow. And then you post it on another site, another, and you keep getting that same feedback. On the other hand, if you post that same thing and everyone's like, there's already products that do that, I don't really care about it, then you'd have to decide, well, maybe they don't know what they're talking about. So again, you have to go out there and try and get some feedback, get some data points, and do your research just to figure it out. On the other hand, sometimes if it's something so new that there is nothing to compare it out there, there's no competition analysis, right? Then you just have to say, I think it's going to, and it's worth the risk of $2,500 or whatever, and my 6 months of man hours and sweat equity to try this out. I'll make a couple analogies to two different other categories that I do is, video games and books. Whenever I write a book or made a video game, we would do a market analysis that just would do a competition analysis. So if I'm doing a book on, C++, how many C++ books are there and do they do well? Yes, and there's lots, but the ones that do really well do really well. And say we're going to do a game and we're saying, we just want to do a game in the casual gaming category, maybe poker games. How do poker games do? And we go look and we find the sales of those other poker games like, wow, these things sell 1 million units a year. Or that's awesome. So let's do a poker game, but better than the other poker games. So you just have to do a market analysis, and that means just doing research so that you realize that, hey, this is a good idea that I have, and I'm going to do a little bit better. And I think that this is going to work. And then the other thing is this. Whenever you're coming up with a product idea, remember the very first MP3 player, right? Was the very first MP3 player the iPod?
No, just
no.
Some USB
there were a
stuff,
bunch of them.
think.
There were a bunch of them, but you know what? They were all made by engineers, and they sucked. No one liked them, right? And Steve Jobs said, this got to be super simple, right? Like you touch one button, you play a song, this and that. And that's when we all started playing with MP3 players, but they had existed way before then. So a lot of times a product category can have a bunch of products in it, but no one's done it right yet. And maybe you're the person who says, I'm just going to simplify this and make it much cooler and make it much easier. For example, in our field of embedded systems, like there was a moment in time before that, no one played with microcontrollers other than real engineers. And that moment in time was the basic stamp. That came way before the Arduino, right? So the basic stamp by Parallax was one of the very first small little embedded systems that you could plug in and do stuff with, program in BASIC. And that's what made that company Parallax. They sold millions of them. And no one had anything like it that was simple like that. You program in BASIC, you get done. And then it took years. There are thousands of embedded single board computers, thousands of them from hundreds of manufacturers. No one used them until the Arduino came out. Then all of a sudden that became the de facto standard. And I'm sure as an engineer, you're like, I can't believe this is the de facto standard. Now it's pretty cool. But at first you're like, it's like this little 8-bit horrible tiny little microcontroller with nothing on it. This is wrong and this is wrong. but it was simple and everyone could program on it. So they did it right. So a lot of times, even if you find in your research that there's a lot of other products and they're not doing well, maybe you can make the one that does better. But again, this is all controlled and tempered by how much does it cost to ask that question, right? You know, so you don't want to put $10 million on something that's very risky, but $1,000 to maybe make 100,000, that's a risk I'll take, you know.
I would like to ask, you mentioned you design a couple of different products. So what is the successful ratio? Like every 10th product can be successful?
No, so I do this process pretty well. I go through and I do my research, I do my homework, and everything that I've made, I've at least probably got back my money, you know, 5 to 10 times. So that's kind of, you know, what I'm looking for, a 5 or 10 times, you know, ROI
on
for
every
doing
single product.
Yeah, every single product. Yeah, every single one of them. And then, you know, and then the other interesting thing is there's like plateaus. And again, you come up with a decent, you go out in the marketplace and you say, here's all these different things, and I'm going to make this, like, you know, all my gaming consoles, right? All my game systems. So they're educational game consoles, right? And there were none in the marketplace. And I knew that the marketplace would only absorb so many of them because everyone doesn't want to learn electronics and building game consoles and all that. So I said, you know, I can probably sell this many of them. So I can only put this much time and effort and energy and manufacturing and all that. Then you have to go out and do all that marketing and prep for it and advertise for it and all that. And then you sell your units and you're like, you know, that's it. That's kind of the plateau you're going to hit with that kind of product. Then if you want to do a bigger product, that's a consumer level product, right? So maybe I want to make an iPhone charger or something like that. That has the potential of selling millions of units, right? Again, you do the same kind of thing, but maybe that's going to cost more because now I need maybe UL certifications, I need FCC certifications, I need injection molding and all that. So that's a much bigger, you know, question to answer. But if you do your homework, and if your product or product category is selling at all, you can, I think you can always make something sell probably anywhere from 3 to 10 times better if you just look at it, look at all the competition and pick the best things out of it and just make yours better, you know, and cheaper. And just be honest about it. When you buy a product, anything you buy, you're like, this is horrible. This should have this and have this and have this. If you just be the customer yourself and just make sure your product is better, you're usually pretty safe. You may not get rich off of it, but you'll at least make your money back. You know?
This is why I bought 3D printer, because I got like really annoyed with some of the things which are like, I have this Oral-B toothbrush and the heads, they sell it with a case which gets wet and you know, bacteria grows there and I don't know, and you can't really buy a good like toothbrush head holder. So I just designed one which is like open, water can flow away, and I'm like, finally I have something what I really always wanted.
Right, and that's another thing. So that's a pain point, right? So a lot of products all do the same thing, and no one addresses the pain point, right? And I use Sonicare toothbrushes to keep along with your example. And, you know, I've got a little daughter and she brushes her teeth with a Sonicare. And if she doesn't wipe all the toothpaste off, the toothpaste has sugar in it and this and that. I know the sugar in toothpaste, and then bacteria will grow on it. So I've got to clean it every day, almost every day. I've got to clean it. And then I've got ultraviolet cleaning that I put it in there and I close it and it cleans it with UV light, right? And kills all the bacteria. But this should be like something that's just standard that someone should address, you know, in the product. So again, it's like when you're designing your product, all you really got to do is just look at things and just say, if this, you know, like there's so many things about packaging, for example, like you get a piece of cheese and you cannot open this piece of cheese to save your life, right? It's like you just ripping it. Like, has anyone tried opening this piece of cheese? I know this company that makes $1 billion a year, Kraft, has tried opening this cheese, but you can't. And it's just put a little tab on it and that would solve my problem. So just like simple things like opening cans or this or that, people just kind of tolerate things. And that's what I think where innovators can come in, just improve it a little bit. You don't even have to be a disruptor. Just be an innovator and just fix it a little bit, whatever the product is. And people, they'll you know, decide on that product rather than the old product, you know?
This is what I noticed with many recent products, like all the development and testing, they just like disappeared because they cost a lot of money and they just manufacture simplest, easiest, fastest products as they can, and no one really
Right.
cares about like designing really good products.
Right. Right. And they train us. Remember when you used to buy like a hardware product, it worked. You would plug it in and it would work. But now they've trained us to download drivers and install things and fiddle with it and all that, right? We shouldn't have to do that. I mean, it's like whenever I get anything new, I just go, I know this is going to take an hour to figure out how to get this to work, so I won't even get anything new, right? And so a lot of people have been conditioned and trained to tolerate bad products, but we vote with our dollars. And so if you give a person a better product or a better something, they'll vote and buy your product, hopefully,
I think you mentioned an example with your friend where he just put a computer inside, installed a software.
Yeah. Oh, yeah. So you're talking about the virus software company, right? So this is years ago, back in the early 2000s. So a friend of mine, so this is when spam was becoming spam, right? So people started figuring out how to email everybody and just bombard everybody. So internet kind of came out, 94, 95, kind of publicly made its debut. And so by, 2000, people were getting spam. So this is early 2000, the early 2000s, 2003, 2004, I think. And so I'm from Silicon Valley, and we all had our little companies. I had a gaming company developing game software, and my friends, they like doing internet companies, right? And I hate internet companies, right? I hated internet. But I would go over there and we'd all talk and bang ideas off each other. And one of them is like, I'm sick of getting all this spam. So I put a little filter in software on the router or something, and then it stopped like 99% of the spam. And maybe we should make a product out of this. And I'm just like, I don't think anyone, I mean, it's so easy. They just like go in there and do one little line of code and it fixes it. He's like, yeah, Andre, but most people don't know how to do that at all. So anyway, we left, and then my friends, what they did was they just took a off-the-shelf computer and just a normal PC, and they put Linux on it. And then they put Spam Assassin on it, which is just a free open source piece of software, and painted a little logo on it. We made the logo for the company because they had a little blue circle which looked horrible, and so like for a half hours we're talking, we kind of drew a logo for them for fun, and because I had my web designer with me that day, and so he painted this thing and put Spam Assassin on it. And I'm like, there's no one is going to buy this thing for I think it was $2,500 they wanted to sell it for. I'm like, no way anyone is going to buy this, because they can just do it for free. They can just install Spam Assassin for free. And he goes, I don't know, let's just give it a try. And I go, okay. So anyway, he went on vacation or something, and then put these up on a website. And then he calls me the next week. He's like, Andre, like someone bought like one of these, and I couldn't believe it. I'm like, someone actually paid for these things? He goes, yeah, $2,500. And then the next day it was like they bought 3 of them. And so all of a sudden these companies were buying these things to solve a problem that they had. And it was really easy because they just didn't have any idea. And even though it was easy for us because we're, computer people, other people didn't get this. They just wanted to plug something in and get no more spam, period. And that's what it did. And so these little $500, $300 servers, spray painted black and blue, they were selling for $2,500 up to $10,000. And it was the same stuff in there. And they just opened up a few more features, and they built a whole company out of it, a multi-billion, the company's worth, I don't know, $500 million right now, Barracuda Networks. And so that's kind of how it started. It was just started inside of an office, and someone had a problem, and just tried it out, and for cheap, and did it really, really quick. I mean, they went from concept to deployment. It was 2 weeks.
Mm-hmm.
It was like spray paint it, put Spam Assassin on there, put it up on a website, and see what happens.
It was like proof of concept.
Yeah, it was a proof of, so this costed nothing. There's no engineering time. You just took a piece of software, put it in a black box, put a logo on it, and then made it so the second you turned it on, you could get to a web page and type a couple things in for your company. So it was a real easy thing to try because it was all pure software, right? And it was a proof of concept. And if it didn't work, it didn't cost anything because they just, built one of them, right? And then had it ready, and then built up a website really quick, and then just see if it works. So this is different. There was no hardware, no manufacturing to prepare. It was very easy where they could just call someone and say, build us 10 of these servers, black, And then they would literally make stickers. They made stickers that stuck on there with their logo, and that's all they did for hardware. And it was, I don't know, 5 years later, after they're making hundreds of millions of dollars, before they even dabbled in hardware. And you know what the hardware was they added to the box?
I don't know.
One little thing. They wanted, because they were black boxes, servers, they just wanted to add some LEDs, a red, a green, and a yellow LED, literally 3 LEDs on a little bar that could plug into it and plug into an ISA bus or whatever, so they could control the LEDs, or the parallel port, I think. And so they could control the LEDs. And that was their big hardware thing, you know? And then later they started building and manufacturing custom hardware, but they didn't build anything for years. It was just software and that. So in our case, when we're building hardware, that's why we do want to keep it simple at first, you know?
Because you get like very quickly the feedback from the people.
Yeah, you get the feedback, and the whole idea is you do something like, just coming back to our LED blinking LED with a 555 alarm system for our car. Someone's like, that's really cool, but I left it on and the battery died. I forgot about it as I drove away. So then they say, if it just could turn off in the daytime, so then maybe you say, maybe I'll put a little ambient light sensor on it, right? Because that's a lot easier than putting Bluetooth on it, right? So I'll put an ambient light sensor and it'll click it off, and if it was some hysteresis, so if the light turns off for this long in the space, then it turns on the blinking light. Once the light turns on for a few minutes, then it turns it off. So someone could give you that feedback, and then you could iterate really quickly, right? And that's good, because then that feedback then helps you sell to other people, But if it takes you 6 to 12 months to go through an engineering cycle because the product is so complicated, that's not going to work. So that's why, doing the simple products at first, and then you just kind of, you start ramping up. Look at, another example is, look at Microsoft, right? Microsoft started with pure software, right? And then they dabbled in mice. Remember, that was like one of the first products they ever played with, was a Microsoft mouse.
Really?
Right? Yeah, they were terrified of hardware, because I tried contacting Microsoft to do a graphics card, right? Back in the 80s, I wanted to do a graphics card, an ISA card, and I contacted them and other companies like, no, we don't want to mess with hardware, none of that. And so one of the very first things was doing the Microsoft mouse. And then now, of course, they manufacture Xboxes, and they're designing chips, right? But they started off really, really simple. They're like, okay, let's just try this. And even the Xbox, right? They didn't design the Xbox. It was an off-the-shelf board, member, and they were like, if you can take an off-the-shelf PC, get the thing to boot in like 20 or 30 seconds, right? And show me a demo, and we'll invest in this. And that's how that happened, They built this prototype, and they went into Bill Gates, and they're like, you got your 5 minutes, show me. And they booted it up, and it's like, okay, let's do this. Let's get into the video game market with this piece of hardware, because I think we can do most of it off the shelf, So with hardware, you just got to keep it simple. You just, for your first things, because you just want to get anything out. And there was an old saying at IBM, when they tried to do the PC computer, was one of the engineers at IBM said, it literally takes us 1 year to ship an empty box. If there was nothing even in the box, it would literally take us a year to ship it. That's why they started a whole new division to do the PC, because they knew they couldn't do it the IBM way. It would just take forever. So they started another small little division, a little group, and their job was, we're going to build the PC, because we can't do things the IBM way. So so just, there's so many other elements to selling, building, manufacturing, and supporting hardware that you just want to start off, make that hardware simple.
Okay. So does it mean like you can, for example, place on Amazon like kind of halfly finished product and test if people are going to buy it?
Well, I wouldn't put a half finished of anything, but here's the thing. Whenever you do a product specification, once you get it to work, once it's manufacturable, once you tested it and it works, instead of putting all the bells and the whistles and the features you want to put in it, right? Just do a version 1, which maybe in our mind is version 0.1, right? Maybe it's got none of the features we really want, but it works, it's tested, I can manufacture it. And yeah, let's go test it out and see if there's just interest. And wow, if I can sell some of these, great, then I can come up with the next version where I add some more of these features, rather than putting all these things in at once, So like, for example, there's a company, I buy a lot of toys. I have a daughter, and then so anyway, there's a company that makes hex bugs, right? The little robotic little bugs. It's
We have
basically a
them.
brush bots, right? Little brush bots, a little vibrator motor and a little battery, and it just vibrates, and that's it. They're called brush bots, and they move around like some sorts of insects or like a gas. Really, they just kind of move around, and that company makes millions and millions and millions of dollars on those things, right? And you might say, hey, let's make another version of it. Let's put lights on it. Let's put 2 motors. Let's put a camera. Let's do this. Let's do that. That's great, but maybe just start off with maybe just put a light on it, just an LED, and let's see how that goes. So, and then I have all these ideas of all these cool things, but that's going to take more time and complicated and this and that. So again, it's okay to put out a simplified version, and you really have to watch out when you come up with your big grand idea. Since you are doing hardware, maybe it's a good idea to say, here's where I want to go with version 2 or 3, but the first version, let's really scale it down, and just because it's a product concept, right? Let's just do this kind of minimum viable product. Let's finish it. Let's debug it. Let's make it clean, and then try and sell it. And then if there is interest, I can see the trajectory of the interest. They definitely would buy the next version, But I don't need to finish off with making the most awesome product at first. And that's another big mistake everybody makes. A lot of engineers are perfectionists, right? They're a little obsessive compulsive. They want it to be perfect, right? And they end up never shipping it. Right? And one thing I learned, that example I told you about my friends, my internet friends, they're the opposite. They don't care about finishing anything. They're like, if they need a driver to install or it's not working all the way, who cares? Because we can do it with software over internet, right? And so they're like, just the second it's working, test it, whatever, ship it, and we can, fix it later or whatever. And so I don't go that far. I like things to work. But again, you don't want to go so far it's got to be perfect, Just get it good, and then ship it, and then you can always do another version in the future. So yeah, I would always say, whatever the product is you want to build, start pulling off pieces of it. You don't want to break it so it's not functional or it doesn't do anything you want it to do, but pull pieces off, set them aside, just swallow your pride and your ego and say, I'm just going to make this version first, and later we'll put all these other cool things in here. I just want to see how it works so I can get it done.
So how does it work on Amazon? Do you sell on Amazon?
I do sell on Amazon. I don't actively anymore because the products.
So what do you remember? How does it work? Is it like simplest way how to start selling?
Yeah, it's super simple. They made it really, really simple. So and there's a couple logistical things. So with Amazon, they basically do drop shipping for you, and they have the products for you. So what you do is you set up an account with Amazon, and like I said, you can go to Amazon sales and you become an Amazon associate or seller. And they've got different categories that cost different amounts of money. The more you pay them per month, and I'm not talking about a lot, it's like $49 or $99 is one of their higher tiers, then they take less of a percentage of the sale. And then there's a margin. So anyway, depending on which tier you take, they might take 15% or 30% off the sale price of the product, and that's what they buy them. But they don't buy them from you. What they do is that you give them to them. So you basically ship them to them, and they're not going to buy anything from you. You ship them to them, and then they sell them. Now, I'm sure Amazon also has categories where they will buy things, but that's on a massive scale where they're going to buy product from you. But basically, your product is on consignment at Amazon. So you ship it there, you put it in the packaging, and then it's going to sit on a shelf with everything else, with all the toothbrushes and the video games and everything else, and someone orders it, boom, the robot grabs it, puts it in the bin, brings it there, and ships it. That's it. And then they count how many of those, and then you get your money every month, and then that's that. And then you have to take care of all the returns. The returns are going to come back to you, right? So it's really, really simple. So that's how something like Amazon works, right? So they do it on consignment.
I think they have also a third option, because I remember when I use Amazon DE, like the Germany Amazon, sometimes the products are directly sold and shipped from China, so they don't even like store them in Amazon.
Right, and they can't. Right, so Amazon, for someone starting off, they'll be your drop shipper. So you're going to give them the product and they're going to sit there. But now other things like, say, bicycles or jet skis, they don't have the room for it all, right? Or they don't want it. So in that case, they become your point of sales, but then you are going to handle drop shipping and logistics of shipping everything, right? So they have that option also, right? If you want to do that. But again, So again, that's a whole nother thing. Like, do you want to sit here and put products inside of boxes, label them, address them, ship them, go to the post office, etc.? So ideally, you want somebody who does the drop shipping for you,
because
and
it's like
worth a
one
couple.
work one time, so you just do everything at once, and you don't have to do it continuously.
Right, and then it costs a little bit of money, but so what? So what? Because it's worth the stress and the pain, and then all the other things that you don't think about, like managing all the boxes and the tape and the packaging and the packing peanuts and there's a lot of stuff. So and then you have to pay someone to do it, because otherwise you're trading your time, an engineer's time, for a shipping receiving clerk's time, which is maybe one gets paid 100 an hour, maybe one gets paid 15 an hour. You're getting paid 15 an hour because you're doing it, right? Unless you hire someone to do it, right? So
does it mean once you list it, I'm sorry for interrupting, does it mean once you list it on Amazon, or is it going to sell itself?
No. So again, Amazon has, I don't know, tens of millions of products. So their search engine is surely going to help find things. So Amazon has papers on, how to get your product up there and so forth. But how their algorithm works, which is, unpublished like all algorithms, but one of the metrics that definitely helps you is people buying your product. But how do people buy your product? That's your problem. So what you got to do is you got to seed it, right? So if you can go out and advertise and say, here's my new product, and you can do it on Facebook, and you can do it on Twitter, and you can do it on this, you can do it on that, and here's the link to buy it at Amazon. Every time someone buys that, it causes your product to go up. So when someone does a search on Arduino, it starts coming up higher and higher and higher, right? And I've seen this and gamed this many times and seen how it works. If you have a product that sells really, really well, it will just sell more and more and more well. It'll just sell better and better. The algorithm will keep pushing it up. On the same token, if your product gets pushed down, it's very hard once it has that downward momentum to switch it and get it to go back up. So you want to really advertise and not just say, I put it on Amazon and money's going to start rolling in. It's not. You still have to drive traffic to Amazon to seed it and get it going, kind of like a jet engine. Once the jet engine's going, it's going, right? But you got to get it going, right? And so you got to always maintain that advertising pressure, and then of course, vendors like Amazon's and so forth, they do, advertisements and so forth. And those advertisements might even include your product somehow, some way. That's great for the products that are selling really well. But if you're one of a million of a certain product of socks or something, it's probably not going to get advertised unless you're in the top 3.
Okay, and I guess you can also buy some sponsors and some positions or something like.
Well, yeah. Well, I mean, the other thing we didn't really talk about, what we talked about it kind of indirectly, is obviously we've got Google. And when someone types something into Google, right, we want Google to find our product, which that used to be a lot cheaper, but now you could spend $1 million a month doing that. But at very least, here's how I look at things. I'm not in competition with everyone. I'm just in competition with the people selling the same thing that I am, right? Now, if I'm competing against Microsoft, I have no hope, right? But if I'm just competing a bunch of other small businesses and hobbyists building a product, maybe they don't even do any Google AdWords, right? And so maybe I'm going to say, I'm going to put in $250, $300, $500 a month. I'm going to do it for 3 months. You need to do it for at least 3. It's not going to work in 1 because there's momentum. There's inertia to advertising. It takes time for you to see the results. And I'm going to put in $500 a month. And that's, $1,500 for 3 months. And after those 3 months, if I made $1,500 more profit, then it was worth it. Even if I made, a dollar extra profit, I might as well do it, right? So, and then use Google AdWords, which then those AdWords show your link, which then goes to Amazon and they can buy the product. So again, it's this big mixture, and they call it a marketing mix or advertising mix, where you're like, maybe you're doing some Google AdWords, you're doing some Facebook, maybe you're doing some Twitter, maybe you're posting everywhere, you're doing press releases. You just have to decide what budget you have with cash and time, and then do it. But you got to do it, and every few months or every month or every 6 months, you got to sit and put on your marketing hat and sales hat and go push your product again, even though it gets tiring, because it does make a difference, because your product, its sales, maybe it goes up and then it starts dying down. If you just let it go, it'll slowly die. But if you keep pushing it up, it'll, and put some effort in there every few months, it'll keep selling, and it's worth maybe 8 hours. You say, for this weekend or whatever, I'm going to put in 8 hours and I'm going to spend $200, $250, $500. And I know I will make more money than that. Like when I used to advertise in all the magazines, I don't have any new hardware products right now because I'm developing them. But when I used to advertise in magazines, I never, ever did not make my money back. So if I looked at my sales before the ad, right, and then I spent the money on the ad, and sometimes I did like quarter page ads, usually a couple times I did a full page ad. No matter what, I always made way more than I spent on the ad. Always. So that means you should just always be advertising because you're always going to make a profit, but even better, you're getting more people to know your product and your brand. And that's the other key. So even if you made no profit, but you broke even, it would always be worth it to advertise. You might as well because you're getting more people to know your brand somehow.
But how do you know what kind of advertisement work the best for you if you do all of these?
It's like, how do you know what numbers to pick for the lottery? Again, you look at all these different channels. You do your research and you have to try them out. You really do have to try them out. And again, they have inertia. And this is one of the big things. People put a big ad. They'll take a page ad out on some cool magazine about their product, and nothing happens. And they're like, "Oh, I spent $5,000."
You are describing me. Like...
There you go. But if you kept doing it, then all of a sudden in 6 months, you all of a sudden see your sales just skyrocket. And here's why. Because a lot of times people got that magazine and they threw it down and they didn't even read it for a month. Then they finally read it. They finally got some time. Oh, this is a cool thing. You know what? I think I'll buy that. Let me circle that. And they circle that and they put it down for another month. Then the next month they say, I got that extra money for my bonus, and then they buy it. So advertising has inertia. It takes time, but once it starts working, then it works well, and you have to keep feeding it. But a lot of people, what they do is they initially put money in and they get nothing, no return, and they get soured on it. So that's why they call, say that a lot of times with marketing, you have to do, like I said, a marketing mix or advertising mix, and you have to use a shotgun approach sometimes and try different channels and see which one works for you, right? See where your customers are. And a lot of time, these advertising companies and these magazines, they have data, like I'm sure you saw, and it says, we've got, males, females of this age, this demographic, this education, reading it. We've done our statistics, and chances are if you do this, then this is going to happen. And you can look at that data to kind of decide, I'm trying to sell a sport, something sports related. I shouldn't be putting it over here because these people are not into sports, right?
Do they share with you these statistics?
Oh, yeah. They just, you need to make sure, they need to make sure you're serious. But yeah, if you call up any magazine and you want to run an ad, they have a whole prospectus with their target audience, their market share, this, that, and all their demographic statistics for you, and you can look at them so you can make a decision. They just want to make sure you're serious because they want to hold on to these documents, but they have to give you that information.
Do people still read magazines?
Yeah, I mean, all you got to do is go to the bookstores, which there aren't that many bookstores, but yeah, they read absolutely, they read magazines. But again, when we say the word magazine, we're not even talking about magazine that are physically printed. It could be magazine or e-magazine, right? All these companies now have online versions of everything, right? So the bottom line is, it's like, where should you advertise now? Before Facebook, well, look at this. Like, remember how there used to be a website for everything? Now there's just Facebook for everything. There's a Facebook page for everything instead of a website and a forum for everything, right? So everything has kind of been collected on Facebook. So that really, I don't like that at all. But when it comes to magazines, all the magazines and all the different categories of interest that people have, whether it's men's fitness, women's fitness, sports, aerospace, electronics, computers, gaming, whatever, there are still many, many hundreds of magazines in all these categories that you can still buy, physically get copies of them, and or look at the online versions. So like Wired magazine, one of my favorite magazines. I love Wired magazine. Scientific America, love Scientific America, right? Popular Mechanics, love them. So I look at these things, and if something's cool in there, then I can advertise in there. So again, it's just one of your channels, right? And then you've got YouTubers, you've got your influencers, right? You've got, your places like your Reddit, you've got your Facebook, you've got your Google AdWords, you've got your standard press release, which is then going to end up in maybe magazines or end up in newspapers, right? By the editors that read them. So, and again, it's like overwhelming. There's so many things to think
That's
of.
Exactly what I'm thinking about. But again, if you have a limited budget, then what would you recommend?
right? But you just take your time, you make your list. This is not something you're going to do overnight. You make your list, all the magazines, all the websites, all the this, and then you say, what's free? There are free press releases. Type in free press release. You can find them. And then it's free to email editors at magazines and at newspapers. That's free, right? It's free to contact the webmaster at some cool website that sells the same kind of things and say, hey, do you mind if I post in your What's New forum so you don't think it's spam about my product? And it's a lot of legwork, and you just make a big list. And then maybe you have the things like, I want to run an ad on the back of Wired magazine or on the back of Circuit Seller someday. I went and checked it out. It's $5,000 or $2,500. So if my product starts doing well, I'll try that and see how that works. But you just start off with all the things that are free or very, very cheap. And then the other things like, and again, it's all about networking. And like when you go on Facebook, there are hundreds of electronics on Arduino pages, hundreds of them, right? So you can't just go on those pages and start spamming them with your new product. But what you can do is when you're about to, I'm coming up with the idea of a product, go join all these pages, join 100 pages. And when you see something pop up, you know, I've got a problem, I've got this filter and it doesn't work and I want to know, can I do this and that? Type in an answer. Start commenting on these things so that you're part of all these forums. And it's a lot of work and you got to do it prior, but you got to create your tribe, right? And now, 6 months later, when you want to advertise your product and you go post and spam on all these boards, forums, pages on Facebook, the administrators don't delete you. They're like, I've seen Andre on here a lot of times helping people with Arduino or circuits or whatever, so I'll let him leave that on here, right? And that's free. But you can't do it at the last minute. You got to prepare and you got to say, I'm going to go on here and take some time every day, 10 minutes, and just answer some questions in all these different forums. So again, you kind of make a big list of all these things. And then, of course, there's things like where you are right now. I'm not sure if you have it, but meetup.com. In the United States, we have this thing called meetup.com, and there's all these categories, right? It can be guys that like fishing, girls that like, you know, cooking, baking cookies, people that like coding, building electronics, robots. And so meetup.com, you go on there and people physically meet up and then they talk about whatever it is they're interested in, Dungeons and Dragons, woodworking, whatever. And then you can go to these meetups. Before you would physically go to all of them. After COVID, now people have been doing it more virtually. But the point is, you get in a room with 50 people all interested in robotics, and a couple people do a talk about what they're working on, and then they say, does anyone have anything they want to say or talk about? You just stand up. Hey, my name's Andre. I've got this new cool robot. It's like Hexbug. It's coming out, except it's got LEDs on it and got 2 motors, and it's pretty cool. You can go to, you know, betterhexbug.com. Cool. Thanks, Andre. And now you just told 50 people, maybe 1 or 2 are really into it. Maybe they go check it out, and maybe they go buy it or tell some friends. So you got to physically get out there also and do your networking and tell people that are networking nodes themselves. And so this is another concept. When you want to get information out there, just telling random people isn't going to help. You've got to tell people that are networkers. So by going to a meetup.com, you're telling a networker. So that's a network node where I'm going to get 50 people at once all to know about something. And the same thing with Facebook and the same thing with Reddit and the same thing with any of these. So you want to find those networking nodes, and that's where you want to put your energy in. Even if it's free, it's still time that you have to take.
One of the ways how you can get the interest is Kickstarter, correct?
Yes. So obviously there's these crowdfunding websites, Kickstarter and Indiegogo are probably the 2 that most people know about. So Kickstarter, for example, has a lot of hardware products on there. And so you can say to yourself, I want to, you know, develop a product, and I want to raise money through Kickstarter to develop the product, manufacture the product, sell the product, and so forth. Now, depending on what kind of product it is, hardware is I think it's the #1 failure point type of product on Kickstarter. And so Kickstarter is a good way to raise money, but you have to be very, very careful because when you do go to Kickstarter, the worst and the best thing that can happen to you is you're successful and you raise a bunch of money, but you have no product yet. You just have an idea and maybe some drawings. And Kickstarter has very strict rules about faking prototypes and using renderings and all that, but people still do it. So Kickstarter can be a great way to raise money, But I urge everybody before you use Kickstarter to actually have the product ready for manufacturing or almost ready. So I know it's a chicken and the egg. You're like, well, how do I do that if I don't raise the money? But the problem is once you take money from Kickstarter, you're on a timeline, you're on a schedule, and the schedule always gets stretched, and you always have unhappy investors, and then you have hundreds, if not thousands, of people complaining to you constantly about where's the product, where's the product, where's the product. And so you don't just have one investor bugging you, you have thousands or hundreds of them complaining, and then they can spam on internet and say that you're lying and you're a fraud. So you have to be very careful. So my advice, and I've gone through many Kickstarter projects with other people, helping them do the engineering, and every single one of them, they grossly underestimate the amount of money and time it takes to get a product, and things like certifications and testing and manufacturing and all those things, and they all fail, mostly fail, and or some version of failing. And so if you do Kickstarter, you really have to get the majority of at least the beta of the product ready. You have to be able to have this thing built and working, whatever it is. And maybe, now I've got 3 of the modules done I need to do. I know how to do them, and now I just need like 4 more, but I know exactly how long they take. I know I can get them done. That you can do. But if you have any question marks, any unknowns, you cannot take the money. It's unethical as an engineer for me. I would never. So a lot of people tell me like, Andre, why don't you go on Kickstarter? You could raise a ton of money. And I go, I won't ever do that until the product is sitting here ready, or at least it's in a deep beta, a far beta, where I know how much it costs. I've contacted a contract manufacturer and said, here's the prototype. The final version will be a little bit different, but it's about the same size PCB. It's 4-layer. It's got this many parts. How much to manufacture 1,000 units, how much to do testing, how much to ship it to me, blah, blah, blah. And I know that number. So if you know all those metrics, then you can go on and say, on Kickstarter, I can raise more money for the actual manufacturing. That's fair. I can hire a couple software engineers to make a bunch of cool apps for the thing. That's fair. And then I can have all these stretch goals to do this and this and this. If I were to get an extra 500 grand, I'll take an extra 6 months and we'll make some other part that goes on it. So you can use Kickstarters, the Indiegogos of the world, to raise money, but I would be very, very careful to do that when you don't have a product that's at a really far beta, and you know the cost of it. You have an idea of the envelope, the worst case scenario. It's going to be $20 or $50 a unit, no more. I know that, right? And I know it can be manufactured and so forth. So you got to be careful with things like Kickstarter.
Is it easy to do Kickstarter?
Yeah, I mean, well, it's interesting. So there are lots of books and lots of papers and lots of information about Kickstarter best practices. There's Facebook pages on this where people want to know what's the magic trick to getting Kickstarter. Here's the problem with Kickstarter. Kickstarter, whenever you put a project up, right, you can look at other people's projects, and some of them are really bad. I mean, they're taking pictures with like, a Kodak camera from 1970. The pictures look horrible. The copy looks horrible. The product looks horrible. The video looks horrible, or there is no video. And then there's a reviewer who reviews these things, and they get thousands of these things, right? And the reviewer has to look at it and make sure they're not like selling porn or lying or whatever. And then they say, good, you're enabled, it's live, or it will be live, or whatever. There's a couple problems. Because of the lack of formality and skill of the reviewers, these reviewers are typically just people off the street that want to get a job at Kickstarter. They don't have skill sets in engineering or art or whatever it is they're reviewing. They don't know what they're looking at, right? But yet they're the people who are judging your product or project. So a lot of times, either they don't understand it, or they have no clue about it, or they think they understand it, and then you've like made this awesome Kickstarter project and put it up there, followed all the rules, crossed your T's, dotted your I's, and they'd like say no. And you're like, why? And then you look at this other project on there, it's horrible. You're like, who reviewed this? So basically, the review process can block your Kickstarter project, and then you will have to go through and try and figure out why.
So it means you can like spend a lot of work and time preparing Kickstarter, and then it can be like denied.
It can be denied, and you don't know why. And it's a really weird process, and I've seen this happen. And then you go searching through Kickstarter, and you find these horrible projects. I mean, like children made them. You're like, who on earth said okay to this, but they didn't say okay to this? Or they'll say these things that are ridiculous. Like, I put up something one time as a test. for a new game console, and they said, we don't do anything electronic or gaming console. I'm like, what? There's hundreds of these projects on here. What are you talking about? But that person didn't even understand what it was they were looking at and had no skill set or talent, shouldn't even be in that job. So that's a frustration that I hear from a lot of people doing Kickstarter. Then the other thing is, Kickstarter, like Amazon, is not like automatic. It's not just going to like magically have people drive to it, right? Kickstarter helps a little bit, but you have to have your tribe ready. And when this Kickstarter goes live, all the people on your mailing lists and all these things, you have to go and do that push and say, you know, it's on there. And then as you do that, then Kickstarter can also, and again, there's a lot to this, but Kickstarter can say, this project looks really hot, and then they put it up on the page and it's like popular. And as they see this driving up, it causes more momentum and more momentum. Just like on Amazon, it'll get listed, and then more people will just look at it. And because millions of people are on Kickstarter every day, and those millions of people are interested in all possible categories, the category that you want, maybe electronics people, see that, and then they'll click on it and buy it, right? So anyway, Kickstarter is not magical. You still have to get your tribe ready and all that, and you have to have a good Kickstarter page, and just a decent video. People think you need to spend tens of thousands of dollars making videos. You can make a video yourself as long as it's clean. People can understand you. There's not rushing wind in the background. The video camera's not shaking. They're going to be fine with it, you know. And I can tell you, like, projects, like can I click something here?
Yeah, you can.
And search for something. Let me see. Kickstarter DigiSpark. So this is a while ago, but here, this little one right here, it's called the DigiSpark, and all it was a little Arduino with a voltage regulator that plugs into a USB and has some pins on it. Have you seen this one, Robert?
No.
And so anyway, you should take a look at this because it'll make you mad. But anyway, when you watch this video, it's literally taken with a cell phone camera and poor lighting and all that. And he raised $300,000 to make this little thing that literally took a night. So here's an example. Someone just made this little Arduino. It took like a weekend, very simple, just a chip, regulator, a couple things, and made $300,000 in sales. And then I think it shows some of the early prototypes here. If I scroll down here, yeah, and this is, you can see it on the solderless breadboard there, and you know, he didn't even make the wires straight. You know, it's so bad. But anyway, it made, you know, $300,000, and that's you know, a good example of this is definitely a unicorn project on Kickstarter. But I love this because it was really simple. He didn't spend a ton of money. He made it. And he's like, you know, it works. I'll put some blinking lights, control a couple things, put a couple Arduino sketches on here, and then put it on there. And then people are like, this is really cool. And he sold this many of them. Then on the other hand, you can do searches and find awesome FPGA projects or single board computers. And they you know, they did a really good job, really good video, but for some reason, no one cared. And there's hundreds of examples of that too. So Kickstarter is also a really good place to do research and to data mine and look what products did well, what products did bad. Can I see anything in common with all their videos, their layout, their copy, and kind of parse and say, you know, here are some best practices when I do my Kickstarter. And in fact, there's a really interesting paper. I can't remember the title of it, but I think it was Georgia Tech or another university. They did this, and what they did was they went on Kickstarter and they analyzed like thousands of the most popular Kickstarters. And then they looked for digraphs, pairs of words that they found in every Kickstarter. And it didn't matter if you had these pairs of words, like big tree, it always did well. And if it didn't, it wouldn't. So just having these phrases manipulated people psychologically to like the Kickstarter. And they correlated it and used machine learning and it analyzed it, just the copy, and using certain terms, put people in a certain frame of mind where they would be like, I want to click on this and support it. So anyway, yeah, so Kickstarter, you know, if you're going to do something on that, just you want to have the hardware ready. You want to go through and spend a few days, and it's really time consuming looking at all these products. And it's also depressing because you're like, wow, I can never make a video like this. This is a produced video. It looks really cool. And then, you know, there was some really cool ones where I saw a couple guys and they were like in China. They'd gone to China for some like little manufacturing thing where they would sit there for like 6 weeks and build a product, just concentrate on it with a bunch of other entrepreneurs. And then I remember, and it was some kind of gaming project, and I can't remember what it was, but the video they made, it's like they literally took a cell phone and started walking from the bottom of the lab to the top of the building, the roof, and just walked. And this poor guy is soaking in sweat. You can see his shirt's all sweaty. And then he's just talking to the camera as the camera is just walking with him. And then at the very end, he comes back down, and then like 3 people throw confetti at him, and he's all, buy this product. And it was just like so crazy. And the product wasn't bad that he got it funded. And I think made like 200,000, something like that. And it was a simple thing like this. So they just made the video right then and just said, let's give it a try. So you don't need to spend a lot of money, is what I'm saying. You just need to do a good job.
Mm-hmm. But, then it's interesting because you already have the product almost finished. You have to also send people or your contacts to the Kickstarter project. Then question is like, do you really need to do Kickstarter project? Like,
yes. Well, the whole idea is yes, because you look at Kickstarter and some of the times it raises tens of millions of dollars for projects. My email list or all the people, maybe I'm going to sell 500 or 1,000 people on it, right? I'm not going to sell tens of thousands or thousands. And again, what happens on Kickstarter is, just like on Amazon, they have access to millions of people that are interested in potentially my product, which I don't have access to. Once you get that going and people's eyeballs are on that, that's going to start going, raising up in their search engine. So when someone types something in, which every day there's millions of people typing in Arduino or electronics or car parts or video games, whatever it is, it's going to find it on that, and they're going to be able to buy it and support your project.
So if you can make the spark, then it can like blow, right?
Right. But so you got it. So basically you've got to set the stage for it to happen, and you've got to get everybody ready, get your tribe ready. And the people that I've talked to that have successful Kickstarters, and I ask these similar questions. I'm like, what did you do? What did you not do? And they're like, I wish I would have done this. But they're like, the number one thing, my first Kickstarter was a complete failure, right? And they showed it to me, right? And they'd show me the page because you need a link to it and I can see it. And I'm like, wow, that looks really good. And he's like, yeah, but I did not have a tribe. I just put it on there and thought it would work. And then he goes to the second one. I spent 3 months and I just advertised and got it ready. And then once I had my email list or my people that I wanted to contact, I said, the Kickstarter's live and here it is. And then slowly I watched it start going up and people start supporting it. And then they told their friends. And then the other thing is, here's another thing. When I talk to a lot of engineers, they're engineers because they like being engineers and not salespeople. If you take an engineer and put them on a car lot and say, sell used cars, they're not going to be good at it, right? You've really got to put that hat on and say, hey, how's it going today? You know what? You would look really good in this Corvette. Come on over here, buddy. Come on, get in this Corvette. Let me try it out. You got to be pushy, and you got to just let go of your ego and who you are. And a lot of times you're like, oh, I shouldn't email or call him or bug him because they're going to think I'm spamming him, being annoying. So what? You got to do it. And it's not like you're doing it 24 hours a day. You're just doing it once or twice. And you got to be able to get this information out here and let people know about it, even though some of them are just going to get, all upset about you contacting them or spamming them or whatever. Too bad.
But this is interesting. This is interesting point because I never really thought about this algorithm effect. And now when you are mentioning this, it's basically the same what is happening with YouTube. Like once I post a video, YouTube will test the video with, I don't know, a couple of hundreds of people, and if it's good, it's going to promote it. If YouTube think it's not good, it's going to get buried.
Right. Well, I mean, this way of testing things, this goes back to the 50s and the Nielsen ratings and the Nielsen boxes, and that's how in the United States they would gauge interest in a TV show. People would get these boxes on their TV and it would literally analyze what they were watching. It was only a few hundred people. It wasn't tens of thousands or millions like you would think. It was literally a few hundred people would decide if the new show on NBC or CBS or ABC was doing well and what their ratings were. That's it. Just a few hundred people. They controlled everything, so like you said.
But I think it's good
YouTube.
enough, is it?
Well, you can make arguments, and again, you can make a statistical argument and say, is this sample group statistically significant for this demographic or this or this? So I would these days, I'm absolutely certain everybody is playing with statistics and lying and not being correct with it and cherry picking data and all that. But if you did it right and you spread it out over the demographics in the different areas, you could, with just a few hundred, definitely have a statistically significant sample where the standard deviation wasn't so large that whatever the person picked isn't so watered down.
Mm-hmm.
It gives you no actual information. So yeah, that's enough information. You just need hundreds of samples, not tens of samples.
Mm-hmm.
But people play with that data.
Okay,
But anyway,
let's we have a couple of more topics what we would like to cover. So let's move to certification. So I think we didn't talk into details like about certificating the product. So
yeah,
is it like hard? What should we keep in mind? What kind of certifications maybe we should
right,
do, or do we need them?
right. So ideally, we want no certifications, right? So when you're designing a product, depending on what channel it's going to go into, there's different certifications that will be, required by law. So, for example, if you're going to transmit radiation, you're going to need to talk to the FCC, and you're going to need an FCC certification if something's going to radiate, right? And if you are going to build a product that plugs into a wall and goes in a school or children are around, you're going to need UL certifications. If you're going to have products that are in the United States and in Europe that are, human beings are going to be around, you're going to need, RoHS, Restriction Against Hazardous Substances certifications. If you're going to sell in Europe, you're going to need their CE certification, and there's other certifications. So the whole thing about certifications is this: depending on what you're deciding to manufacture and sell and so forth, you have to find out what certifications you need. So, for example, if you're going to build a simple hobby toy that you assemble, you can get around most certifications unless you're going to sell it into a channel that requires those certifications, right? Now, some of the certifications I just listed off. So the RoHS certification, RoHS 2 certifications, which are the restriction against hazardous substances, certain metals, lead-based solders and so forth in your product. Those are self-certifications. You can fill out forms and documents, and you can stipulate that your product is free of these things. The same thing with like the CE certification for selling in Europe. You can fill out a bunch of documentation. You certify that your product meets these requirements, and then every year you have to kind of resubmit this, and there's a process of doing it, but it's basically free. Once you move up to needing things like UL certifications and FCC certifications, these become very, very expensive. So, for example, I'll just pick a random thing that I've made before. Is I do a lot of industrial products, right? So they're boring, but people need them. So, like, for example, I did one time an exit light system, and this exit light system was going to go in 10,000 hotels in Las Vegas and other places around the United States. So if you're going to build an exit light, you can think of some group, somebody has said, well, if an exit light has to be battery backed up, it has to be visible at a certain distance, it has to be able to be powered under these circumstances, it has to this, it has to that, it has to last so many years. And so, for example, Underwriter Laboratories has a bunch of certifications that the hotels require you to have.
Mm-hmm.
It has to be UL certified for these certifications. So the process is, I go out and I pay hundreds of dollars to get these documents from Underwriter Laboratories. And this, of course, for those of you that aren't in the United States, Underwriter Laboratories is a certification lab in the United States here. It's been around decades and decades that certifies products for safety for people, electrical products and other products. And so you have to get this document. And so they say, you need certification 2178 and 3152. And so you go buy those documents from Underwriter Laboratories, which usually costs in the hundreds of dollars each. And it's a PDF, and you read through it, and it basically lists, here are all the rules. If there's metal touching metal, if there's this doing that, you have to follow all these rules. It can only pull this much current. It can only radiate this. And anyway, you design the product around that. When it's all done, then you're going to submit your product prototype to Underwriter Laboratories and or to a testing lab, which then can help you give it to Underwriter Laboratories and have them review it. So that's a whole other thing. There are these labs, certification labs, that will help you with this process that you pay and they help you through all these different certifications you need. But anyway, just talking about directly with UL Labs, they'll look at the product, they'll test the product, they'll take it apart, do whatever they do, and they'll usually come back and either certify it and say you passed everything, or they'll say this is wrong and this is wrong, and then please resubmit it, which is kind of normal because they just want to make more money and they want to find something wrong. Once you find those things are correct, or you fix those things and remedy them, then they will give you the certification. They'll give you a code. They'll put it in a computer, in a database, so it can be found. You can put it on your product and say it's UL certified. Now, say, for example, you don't have the money to do that. Say you want to make a product, and this product requires a power supply that goes from AC to 12 volts. So instead of you designing that power supply, you just go out and buy a UL certified power supply. And that's why it's important that power supplies are UL certified. Of course, you got to be very careful that it's really UL certified. If you buy it from China in bulk, it may not be. It may be a lie.
It has the sticker, yeah, but you will never get the documents.
So you need to go look at the number, look it up at UL, make sure it's authentic and all that. But that's how you can get around using a UL certification. So maybe there's some parts that you can get off the shelf that may be more expensive, but they can save you having to certify yourself. For example, say you need a very complicated power supply. It's much cheaper for you to design it in the board, but maybe you can get one that's already UL certified. And then maybe instead of building your own power supply, you can get a UL certified power supply module and just plug that into your board for the second stage of your power requirements, as an example, right? So that's that. So you do need these certifications because you can be sued by these companies. They can shut you down completely. Now, then of course, the worst one is the FCC. The FCC is real serious about you playing around with anything that radiates any kind of signal that could disturb transmissions from medical or police or fire or airplanes or any of that. So if you're going to make a product, there are lots of rules here about radiation, and you have to read about these rules. So if you make a product that's not what's called an intentional radiator, you're just a circuit board, right? And you've had a lot of videos on keeping EMI and RF radiation and how to, make a Faraday board and all that so radiation doesn't get out of boards and so forth and all that. So even if it's not an intentional radiator, it's not even a transmitter, you have to make sure that it's not radiating, and this potentially has to be tested so you can certify it, because if it does, you could be in big trouble. So if you do develop an intentional radiator, something that is a transmitter or transceiver, then you're going to have to get FCC certification, and this is very costly. From $10,000 to $100,000 is kind of the range. You're going to design your board. It's going to go to the FCC or our testing lab, and they're going to help with this. They're going to test this board. They're going to put it in a chamber, and they're going to, look at the emissions from it and do the test and run the test and see if it's within power requirements and power output that are specified with, whatever you're doing. This is very costly and very expensive. So you say, well, God, how do I get around this? Like, I've got an ESP32 here that, transmits on Wi-Fi and Bluetooth. Can I use that? Yes, if it actually has an FCC certification. So ESP, that company that does the ESP, for example, little module that does wireless, you can use something like that. So one of the things you can do if you're going to do a wireless product, instead of trying to build something yourself that's cheaper, just putting the chip on there and putting an antenna, that technically is illegal. And this is a gray area that a lot of people just want to pretend is not happening. But there's a lot of companies that sell a lot of little products that have chips and antennas. These are not FCC certified. The FCC simply does not want to go after everybody. But I'll tell you right now, the FCC fines you, it's something ridiculous. It's something like $10,000 a day or $100,000 a day if they find out you have a radiator that's not licensed and it's out on the market. And there are horror stories of people telling about what's happened. They found them like at a computer fair, like an electronics show, and you had a product, and there just happened to be an FCC auditor there. And he's looking at products, and he's picking the products up. And he's like looking at the back. I don't see an FCC certification. I see a transceiver on here. And they talk to him. The next thing you know, you're getting this fine of $10,000, $100,000 a day. It's crazy. So if you're going to do wireless things as a new product, I highly suggest you use something that's a module that's already FCC certified, so you can just use it and not worry about it. And you can use their FCC certification. Now, there's one level below that where you can design something where you put some of your own design elements, and it's called it's a certification by similarity. And so what happens is that a company like, say, TI, they'll say, you can design around this chip, and here's a reference design that you can use and put on your own PCB to save money. We've already done most of the work with the FCC and got this certified. As long as you follow our rules here and you follow our layout rules and our antenna rules, you can pay only like $800 or $1,000 and you can get FCC certification by similarity. You still have to go through the process a little bit, but it's not $100,000 or $20,000. So that's what I'll look for. If I really want to save money and I want to do something and I don't want to use a $7 module because I could do it with 70 cents, then if I can find a company that has a reference design that's got similarity certification, then I can go that route. So for hobbyists, you're going to do a RoHS self-certification. You're going to do a CE self-certification. If you need anything wireless, I suggest you use something that's got a wireless FCC certified module. That's kind of where you want to start. And later down the road, you can do other things. If you want to really dig into this and do something complicated and you need UL certifications and FCC certifications, I highly recommend you talk to a certification lab. In the United States, there's a lab called MET, M-E-T Labs, MET Labs, and there's other ones also. And they'll give you a consultant and you basically talk to them and you explain to them what it is you're doing and they can help you navigate through all the certification process if you're going to do something. And this is really only going to matter when you're doing consumer, industrial, medical products. If you're doing hobby products, most hobby companies kind of just like turn their head to it and kind of sell these things when they sort of shouldn't. But no one seems to, the FCC doesn't seem, or UL doesn't really get too irritated by that. But if you do a consumer product, you definitely have to be careful of UL and FCC certifications.
Now the question is, what is product? Because if you just build a board, is it a product?
That's another gray area, right? So there are rules on this, and again, you can Google it and look it up. But here's the rule, and here's how a bunch of people get away with it. It's like if you have something and you have to assemble something, and plug it in, then you can kind of say it's assembled by the customer and it's not a complete product. And that helps you get around certain rules. And so there's actually an interesting, I don't know if it's still up there, but on Spark Fun, they have a whole kind of white paper on this about their experience with it without, they don't want to put themselves in jeopardy. So they're careful what they say. But if you go to Spark Fun and type in something like certifications and do I need a certification or FCC certifications, you should find this white paper on there on Spark Fun and read about, if you want to build these kind of hobby products, what you want to do is have some assembly portion to it. And that kind of gets you out of being in trouble with some of these bodies like the FCC and so forth.
Because I think the product is like really complete product. Usually product is in the box and something like this. But if you just sell a board which can be mounted somewhere, it may not really be like complete product.
Right, and we all tell ourselves that, right? That's what we all do. So
but if you are selling boards, you should at least do some kind of preliminary certification, because someone who is buying your boards may need go through the certification, and that's why you would like to do it.
Now, let me tell you though, as an ethical engineer, I always over-engineer all my products and I make them safe. So if I could pay for the FCC or the UL or whatever, they would pass it. So for example, if I make anything that's going to be around children, even a toy or something, I make sure that it's absolutely safe, right? So I'll go look up those UL certifications. You can find PDFs online and say it should do this and do this. Like, for example, if you have a USB cable connected to a toy charging and a child could be holding that toy and there's a lightning strike, it could kill the child. So you have to have lightning protection on these USB lines, right? So things like that are very important. So I over-design everything. Like I did a product one time where a customer was making a children's toy. And I'm like, I'm not going to build this toy unless I put an aluminum scatter shield around the battery. Because if this were to explode, it could hurt somebody. So I want a piece of aluminum over it and under it. And I don't care how much it costs, or you can find someone else to do this. But it's not required, Andre. And I go, it's required for me. Just because somebody hasn't figured out that this is dangerous, batteries explode. And if this were to explode, it could hurt someone. And now I'm right, because you saw that big rash of all the hoverboards with the giant lithium-ion batteries going out of control and exploding. They hurt a lot of people, burnt houses down because they had their hoverboards charging. So anyway, a lot of times, even if you don't require the UL or the FCC, design for it. You know what I mean? Just do it for yourself so you could rest easy and say, this is super safe, you know, and it can't ever hurt anybody.
I have, you should do it also because, not only because it is the right thing to do, but it can actually go or come back. Because if there is, these certifications, they are not for nothing. They really are created because they can help, or they are helping. So if your product is would be failing some kind of certification, there is a reason why it is failing, and it means your product is bad. And once you start selling it, there is very high chance that people will start returning the product because it will fail.
That's a great example. Let me tell you a little quick story about that. So when I do video products, right, anything that generates a video signal, right, and like my older products all generated an NTSC signal, right, or a PAL signal. So because, you know, most people can't test that, they've got a TV set or 2 TV sets. How do you test it? How do I verify that it works on every possible TV? So I would go to TV stores with my product in my hand, and I would plug it into all these TVs. And I would test it, and all of a sudden I'd find out it doesn't work on a Magnavox for some reason because my timings were a little bit off, right? So I'd go back home, I'd fix it and say I need to adjust it more to the spec, and I'd come back and test it. So you're right. A lot of times, you know, who can test against 100 different television sets? And when I used to make video games, we had, I don't know, we had about 50 computers on racks with every version of Windows and every kind of graphics card and sound card possible at the time. And we would clone the operating systems on the computers and try our games on every single computer to make sure it worked. Most engineers don't do that. They don't go through anything rigorous like that, especially at home. So the testing can actually help you, like you said, find this out under certain circumstances. This is not going to work and it's going to fail. And not only is it going to fail, it's going to break it possibly, you know, so they are important, you know.
Okay, so there is still this manufacturing topic what we would like to talk about, but it's like, can we do it like very quickly? Like,
yeah, I think I can do it in like 5 minutes.
Okay, so what is important about manufacturing? What we would like to know? We have the product, we would like to sell it, we have customers, we need to manufacture it.
So yeah, so what you're going to do is, I mean, you know, typically if the product is a really expensive product, you're going to sell for $1,000 a unit. You can usually manufacture it locally, say in the United States, United Kingdom, Europe, wherever you are, Australia, wherever. But if not, in most cases, you're going to want to manufacture your product in China. And so what you're going to need to do is go out and find what are called contract manufacturers. You can Google for them and find them, contact them, engage them, and they're pretty straightforward. They're going to say, you know, send me your Gerber files, a BOM, and send me a document that describes your testing process. So you're going to engage with these manufacturers, and they're going to basically start quoting you how much things cost to manufacture, how long it will take. Then there's other things, like if you're going to build something that maybe it has a test jig and you need to supply the test jig. Something plugs in, you're going to, you know, maybe there's a firmware test that does something. So a lot of times you'll have to ship that to China, right? To do this right, you're going to, you know, talk to 3 to 5 manufacturers, you're going to get prices and so forth. And it's going to be a long-term relationship. So you really want to be able to work with them and have someone that speaks English or at least can type in English and understand you. But when you get to the manufacturing process, typically what you're going to want to do is, at first, you're going to say, hey, I like your prices for 300 or 500. I want to do a first sample. So you'll send them all the information they need, the BOM, the Gerber files, pictures of a finished product, and I will always send an entire version of the product to the Chinese manufacturer so they can physically see it, test it, and try it. I'll have them make a first article, maybe 3 units, ship them back. Maybe it costs a couple $100, whatever it costs. I'll test them out, try the other manufacturer, and say, these guys really do a good job. So that's how you kind of engage with the manufacturer to work with them, right? And most manufacturers, you're going to want to do research, background research on them to make sure they're legit and so forth. They're usually going to want 30 to 50% of the manufacturing cost up front. And when they deliver the product, they'll deliver you the first articles, and then you'll verify they're okay, and then they'll finish the rest of them and ship them to you. So that's kind of the process there. The other thing is, you want them to do all your parts. You want them to source all your parts. You don't want to be messing around with sourcing parts unless there's some special parts. Now, for example, you might have a product that has a LCD or maybe a battery, and maybe you can find a source, you want to use a specific source for that product, and then you can tell them and they'll get it from them, or you can buy them and ship them to them. But you really want to minimize that. And they're going to get prices, and they're going to go to Avnet, they're going to go to Arrow, they're going to go to Future, they're going to go to wherever they go to get these parts to manufacture it. So that's kind of, you know, the getting the thing done as far as the manufacturing goes. And it's pretty simple. They do this hundreds of times a day. They have hundreds of clients. And so you just send them all the files. They're going to quote you prices, and they're going to, you know, and then you're going to say, great, can you build me a sample so I can see your work? Great. And then you kind of go from there. So that's kind of the process of, you know, getting a manufacturer kind of in the simplest form.
Do you need to order like many pieces to get them talking to you?
No. The Chinese manufacturers, it's not like in the United States where they want a minimum order of like 1,000 units or something. The Chinese, they'll build 25 if you want, right?
Mm-hmm.
So it's very common to do a quote for 100, 300, and 500. That's kind of, you know, kind of a standard. They're okay with that. You don't need to build 10,000, 100,000, anything crazy like that. So I usually do 100, 300, 500 and just be done with it. Now, there are also some companies like PCBWay and what is it, JLC PCB.
I use them,
and
yeah.
PCB, Phoenix PCB. Some of these companies now also do, they'll do assembly for you as well. And so they'll do everything for you. They'll build the board, they'll do the assembly.
But they don't test it.
Right. Well, some of them will do testing, but if they don't, then yeah, you're out the testing. And that's another thing. You never, ever want to ship a board to the United States unless it's been tested, because then you'd have to ship it back, or whatever country you're in, because you're going to have to get through customs and all that. So you have to have a very in-depth test procedure. For me, I usually write a document with pictures and instructions. Then I make a video and I actually show myself or another engineer testing the product, loading the firmware, and I teach them how to load whatever firmware, software, tools are needed to test the product, and I actually show it being tested. Remember, unless you're Chinese and you speak Mandarin or whatever language you know, in Asia that you're using as a manufacturer, they're probably not going to speak your language natively. So you want to have as much video and imagery as possible. You know, an image is worth 1,000 words. So whatever you can show visually is going to help them so they can see it rather than read it. So that's very important also when you're dealing specifically with Chinese manufacturers. So I do videos of everything.
I have same experience.
Yeah, and do books and documents of everything. And even my BOM, it's an Excel spreadsheet, but I have a picture of the front and the back of the board so they can see it. They're like, oh, that connector is what he's talking about with, you know, H1 or whatever, J1, right? And they can see it. And then, of course, when they're going to build it, I send them a sample. I want them to hold a working sample, plug it in, turn it on, and all that. So,
you mentioned batteries. Is it like problem with batteries?
No, it just may be that. So when you're manufacturing something, you know, you may have a specific battery that you like, right? And so it may be from a specific manufacturer. So you might just say something like, you know, you have to put in a lithium-ion battery that has these specs and this C rate and this and that, and they'll find one for you.
But
right?
What about like moving batteries around the world?
Right, that's a problem, right? So that has to go through customs, okay? And so again, so this is another problem when you're shipping your product. So now here's another problem. When you're shipping your product from China to the United States, you're going to have to declare what it is. And I'm just going to talk from the United States. Other countries have their rules, but they're similar. You're going to have to declare what it is, and you're going to have to pay customs fees potentially, right? And also you're going to have to make sure that the product is safe for shipping and get those certifications. So I've shipped things over sea on boats and in air most of the time, right? And so a lot of times the manufacturer can handle the logistics of making you understand what's required, right? And they can say, we're going to send, if we send 1,000 boards at a time, we're going to have to follow these rules. But if you only do 100 boards at a time and it's only worth this much money, it can get through customs with this certification without any problems. And so we'll just send them in boxes of 100, right? That kind of thing.
Mm-hmm.
So you're going to have to talk to them. Now, if you have something big, like one time I designed, do I have one here? No. I designed a game controller, a joystick, real simple one, injection molded with a little circuit board. I ordered a couple thousand. That had to come by sea. So So basically, I worked with the manufacturer who put me in contact with the logistics coordinator for sea travel, and it took 10 days or 15 days. They put it on a boat in a container. It came to the United States. Then the other end, there was another customs company that took the product. They moved it wherever they needed to move it. Then finally, I went and drove and picked it up in a truck, right? So anyway, ideally you want to minimize these things, and if you're only ordering 100, 200 and they're small, they're going to fit in a box and you can avoid most of these things. But the Chinese will help you understand what's required for this.
Okay. And this is the end of the part 2 of our interview with Andre. If you haven't seen part 1, check it out. Thank you, Andre, for this great interview, and thank you for watching, liking and commenting. We are preparing some very interesting tutorials, so if you don't want to miss them, hit the subscribe button. If you want, you can also check out our FedEvel online courses, where you will find everything important from basic board design up to advanced hardware design and PCB layout. The link is in the description. That's all for this video. Thank you again and see you next time. Bye.